Hi and welcome to the demo lesson that will be probably quite long because we have to deploy some code, something that we don't do it usually. We don't do usually because it's a bit slower. But I think that it's necessary to show you how to auto-scale your streaming pipelines. And here I will use this auto-scaling feature on top of two frameworks, Apache Flink and Apache Spark, and I will start by Apache Flink. And my job is maybe not very representative because it processes some numbers, but the goal here was not to have something that will be really real world, but more to find a simple use case that will be CPU intensive, so that I will generate a lot of load on the CPU that will trigger a scaling action on the cluster manager, which will be Kubernetes for that case, and will start typically new workers to process the data. It's not very complex, I would say. I'm doing some complex math that I found somewhere on Stack Overflow, and it works. It's generate some intensive CPU work. And as I said, the processing uses Kubernetes, so I have to deploy some Docker containers, and for that I'm building my project and I'm copying simply the jar to the initial Apache Flink Docker image that I will run on Kubernetes. So to run the code I will use Minikube just to do some cleanup. And I will start the Minikube. Okay, the Kubernetes started. And I will also start Kubernetes dashboard because it will simplify a lot the explanations I will have. So to open the dashboard, I will use my private browser, where you can see that I've not that much things running because I'm just in the beginning, so that's normal. The next step in my workflow will be to build this file, so I will add a new Maven configuration with clean install command. So I have my clean install command and I will generate the jar just now. Okay, and now I'm gonna to publish the Docker image to the Minikube Kubernetes cluster so that I will be able to use it later. So I have my Docker image. I'm now loading it to Kubernetes, to Minikube, sorry. And now I will just check whether it's there or not. Yes, I have my Flink reactive mode demo, of course, with the latest version. I don't care about the versions here, but of course, on production is best to have a specific version deployed so that you know what is running and what should be fixed eventually. And I will also need the metrics server because it's one of the add-ons or components used by horizontal pod autoscaler, which is involved in Apache Flink reactive mode for autoscaling. So put another words, thanks to this component, Kubernetes knows how and when it should start adding new workers to the processing. And so after enabling it, I will create a new namespace for this demo, set the current context, and just in case I will do some cleanup for the Flink components. Okay, they don't exist. I will just check if they exist here. Yes, we have. Okay, everything is there. Now I can start each of the components. Created. Great. I will select my new namespace, go to the pods, and go to the task manager and try to find the CPU dashboard. where it is. Okay, maybe it will be more visible. Okay, I just missed the information. So I have my CPU usage. Okay, we can already see that the CPU usage is pretty high. So now I will enable the auto scaler for Apache Flink, and we should see some new pods added to the workload part dynamically, just to absorb all this CPU pressure. So yeah, we have even higher than 50%. And yes, you can see already that Kubernetes just created a new pod to handle this extra memory pressure on the fly. And just to show you that I'm not lying, that we have some real computation made on these pods. So I cannot see the logs in there. So maybe I show you the others which are already running. So here logically we should see some math. Yeah, we have some math results, and maybe just wait a few seconds more to see the same for the just created pods on task executors. So do we have something? Yes, not yet, unfortunately. As you can see already, it's this operation, even though it's managed fully by our cluster manager, it's not immediate. So still you will need to wait some time, so maybe a few seconds, few minutes, depending on the resources that are available, to see your workload changing. And here you can already see that I'm in the new task manager that is already processing the data. So that's all for Apache Flink and the reactive mode, which is the feature that lets you scale your workload seamlessly. So now I will do some cleanup, delete all the pods, stop the Minikube, and delete all the Minikube resources, including the Apache Flink context. And I will start Apache Spark demo from scratch on a fresh structured streaming instance. So here the logic is very similar. The goal is not to have something complex or, I would say, difficult to understand. Yeah, you can see that I'm simulating the auto-scaling feature in Apache Spark with a simple sleep. And you must know that this feature in Apache Spark is a little bit different. Here I will show you a metric that is auto-scaling strategy that relies on the data processing progress, meaning that if your job is too slow processing the data, it will simply create a new compute resources and allocate all pending tasks on them. And in Apache Spark, this strategy is called dynamic resource allocation. And the idea is to have some tasks that are sleeping for a long time, which is longer than the threshold for the resource allocation. And so that Apache Spark framework can ask Kubernetes to create more executors, and these executors will simply take the responsibility for executing the idle tasks on the cluster, hoping for a faster finish. So yeah, here it's this slowness simulation, and later I will do the same setup as for Flink. So yes, delete, I've already done it, so there's no Minikube cluster. I will start Minikube cluster again. Okay, I will open the dashboard. So here is my new And now I will build the project. And to build the project, I will again add a clean install command. So let's build the project right now. Meantime, I will copy the command to build the Docker image. So for me, the Docker image is very similar to the Apache Flanks. I'm using data mechanics image for Apache Spark 3.3.0. I'm copying my jar to a work directory from where I will execute it later with Spark submit. Okay, my jar is now fully ready. I will build the Docker image. I will save the image. Okay, load the archive to my Minikube cluster and again check whether it succeeded or not. That's nice. Minikube ls, we have streaming auto-scaling, great. So now I will set up the execution environment, define the driver pod name, the Kubernetes namespace. I will create the namespace and set it to the current context. I will also create the service accounts that are necessary to manipulate Kubernetes resources by Apache Spark, and later I will go to my local Apache Spark distribution and update the log4j file. So where's my mistake? Okay, I think it's here. Sorry. Yes. No. Let me take the command from the README. Okay, it's echo. So there's some issues with it. Great, I have my log updated correctly. Now I will check the master address for Kubernetes and export it to a variable so that I can just reference the variable later in all the places. And in the beginning I will start I will now set up the job. So here the configuration that is the most interesting for us is all this dynamic allocation. So shuffle tracking is to know whether we can remove an executor or not. If the executor doesn't store any shuffle files that are required for the computation, well, we can simply remove it. If not, well, it should be kept running. Later we have the schedule, the configuration for the dynamic allocation. So if there is a task for 15 seconds or more, of course we will start a new executor and try to allocate pending task on it. If an executor is idle for 2 minutes, we will try to shut it down. And there is also a configuration for the max number of executors, because if you have a cluster or a limited scaling capability, well, it doesn't worth putting too big number here, because Spark will never succeed to meet your expectations. So okay, and I will now start this job and open the namespace on my cluster. Okay. In my new window, I will forward the ports so that I can see in Spark UI as well. Okay, so you can already see that one task is running and this single task is stuck for the reason you certainly know. And now we have already one executor created dynamically, and we should see a few other executors created on the fly for us by Apache Spark collaborating with Kubernetes Resource Manager. So there is the case for the third executor, the fourth one, and typically here that you can see that we have tasks that are taken into account by these executors. So I don't know if you will see the 6 task taken into account by new executor. So even 7, I think that should be allocated soon. So we have 3 that are running. Maybe besides the second executor, we had allocated these tasks on different ones, including the executors created dynamically just here by Apache Spark, by Kubernetes. Okay, so now I can stop this job and show you another important part. Okay, and another important part shows that there is no like sky is the limit phrase that you can apply, or the sky is the limit logic that you can apply to this problem, because there is always some hardware limitations. And here, since I don't have any I would say machine provider, I have only my single machine and I cannot scale it indefinitely. Of course, there are different tools that I will show you later that can help you mitigate that issue, but still here you can see that I defined the max executors numbers to 50, and spoiler alert, you will see that we have some kind of resource starvation in this part after running, I would say maybe the 7th or the 8th executor. Okay, I have this. Now I have the 6th executor. It started also. And now we have the 7th one. Will it run or not? Okay, it's in pending state. So that's probably the one that will start struggling. And is there some? Yes, there is some information. So typically here we need more compute power, but we cannot afford it because of our hardware limitations. And if you don't want to suffer from this problem and you are on the cloud, so we have some elastic demand capacity, so you can demand the capacity from quite elastic and scalable way, I would say. You can use the tools like Cluster Autoscaler, that, as you can see, is a tool to adjust the size of your cluster automatically when there are, for example, the pods that cannot be started because of insufficient resources, which is typically the case here, or that are the nodes that have been underutilized. So that's generally all for this demo. I finished with this a little bit pessimistic example, but only to show you that the autoscaling is not a silver bullet if you don't have a solid setup behind. And this solid setup behind, you will not be able to make it alone in your own. You will need to collaborate with your DevOps colleagues to do this auto cluster setup safely. And for example, not only from the, I would say, data safety perspective to avoid data breaches and all, but also from the cost safety, because yes, unless your company has very, very nice finances, you will probably not be able to auto scale indefinitely, meaning that yes, you can simply burn out your budget and put your company into trouble. So remember that the auto scaling is not magic. You need some solid DevOps setup behind, but if the solid setup is there, your data processing frameworks, so either Apache Flink or Apache Spark, have all which is required to adapt their cluster capacity to the current workload. Thanks for watching and see you in the next lesson.